Welcome everyone to MHD Studio, and in this video we'll discuss big data. The term big data seems to be popping up everywhere these days, and there seems to be as many use of this term as there are contexts in which you find it. Big data is often used to refer to any dataset that is difficult to manage using traditional database systems. It is also used as a catch-all term for any collection of data that is too large to process on a single server. Yet, others use the term to simply mean a lot of data. Sometimes it turns out it doesn't even have to be large. So what exactly big data? A precise specification of big is elusive. What is considered big for one organization may be small for another. What is large scale today will likely seem small scale in the near future. Petabyte is the new terabyte. Thus, size also cannot specify big data. The complexity of the data is an important factor that must also be considered. Most now agree with the characterization of big data using the 3 V's coined by Doug Loney of Gartner. Volume, this refers to the vast amounts of data that is generated every second, minute, hour, or day in our digitized world. Velocity, this refers to the speed at which data is being generated and the pace at which data moves from one point to the next. And variety, this refers to the ever-increasing different forms that data can come, in text, images, voice, or geospatial. A fourth V is now also sometimes add veracity. This refers to the quality of the data, which can vary greatly. The V's are the dimensions that characterize big data and also embodied its challenges. We have huge amounts of data in different formats and varying quality that must be processed quickly. It's important to note that the goal of processing big data is to gain insight to support decision making. It's not sufficient to just be able to capture and store data. The point of collecting and processing volumes of complex data is to understand trends and cover hidden patterns, detect anomalies, etc., so that you have a better understanding of the problem being analyzed and can make more informed data-driven decisions. In fact, many consider value as the fifth V of big data, which is processing big data must bring about value from insights gained. To address the challenges of big data, innovative technologies are needed. Parallel distributed computing paradigms, scalable machine learning algorithms, and real-time querying are key to analysis for big data. Distributed file systems, computing clusters, cloud computing, and data stores supporting data variety and agility are also necessary to provide the infrastructure for processing of big data. Also, workflows provide an intuitive, reusable, scalable, and reproducible way to process big data to gain verifiable value from it and enable application of same methods to different datasets. With all the data generated from social media, smart sensors, satellites, surveillance cameras, the internet, and countless other devices, big data is all around us. The attempt to make sense out of that data brings about exciting opportunities indeed. I hope you enjoyed this video. If you liked it, give it a thumbs up and don't forget to subscribe and hit the bell for more interesting content, and thanks for watching.